everyone, my name is Ravi and welcome to first class of number series. So number series is a very important topic for all the examinations like bank, SSC and all the non-CAT examinations like IFT, SNAP or this NMAT. Okay, so we'll discuss all the possible kinds of number series with all different logics. Okay, all the possibilities we'll discuss here, right? We'll start number series. Okay, see. First type of number series basically we'll see. So first type is basically you got to get the difference, right? You got to get a difference wise says. Okay, so difference, where from difference you can undergo which kind of series it is, right? With difference. Okay, for example, you have a series like 19, 23, 39, okay, 75, and then this is a blank here, okay, and then it is 239. So to fill the blanks, right? What is the series here? Fine. So 19, 23, 39, 75, 239. What is the series here? So once you get a logic behind it, right, which kind of series it is, you see here. So first thing is to see that, okay, this series is not increasing very fast. Okay, actually increasing very fast will be a multiplicative series kind of number, right? So we'll discuss it in the later part. Okay, with this series you can observe this series not increasing very fast, right? Difference here is 4, okay, difference here is 16, difference here is 36. Okay, so you can go by the difference here, right? Now by going by the difference here, what you can see is try to get the pattern, right? So what is this 4? So this 4 is 2 square. What is 16? It is 4 square. 36 square. That means from here to here difference 2 square. From here to here difference 4 square. From here to here difference 6 square. So next should be difference 8 square. That is 64. If I add it, you'll get 75 plus 64. That is 139. Okay. And then next should be 10 square. That is 100. If you add 100, you get 239. That's fine. It is satisfying. That is my answer. Therefore, my answer for this question is what? 139. Right. So it's a bit of difference, right? That's what I'm saying. It is difference series. By difference, you can understand the pattern here, right? Which kind of pattern is going on, right? Okay. This is the next question here. 77, 83, 101, 131, 173. What is the next number, right? So again, you can see series is not increasing very fast. You can just get by the logic of the difference here. Difference of 6, difference of 18, difference of 30, difference of 42. So if you observe here, the numbers are going on. This is basically 6 into 1. This is 6 into 3, right? This is 6 into 5. This is 6 into 7. So these are alternate odd multiples of 6. Okay. This number here is 1. This is 3. This is 5. This is 7. Okay. So next will be how much? So next odd multiple of 6 is 6 into 9. That is 54. So if you add 54, 173 plus 54, it will be 227. Right, 227. Fine. So now this difference could be anything, right? This difference could be basically anything. Okay. Okay. This is the next question here. 242, 289, 332, 373, 410, 470. Right. Now again, you can see this series is increasing here, but not with very high. It is not increasing very fast. Okay. So I can just go by the difference here, right? So if you see the difference here, what the difference here is now? 47. Okay. What the difference here? 43. What the difference here? 41. What the difference here? 37. You got to observe what is happening here, right? 47, 43, 41, 37. Here 4 decreased. Here 2 decreased. Again 4 decreased. Right? Now, so if what you can think is, okay, if again 2 will decrease here. Okay, if again 2 will decrease here, so it becomes 35. I'm just telling you logic, right? 35. So if you increase 35, it becomes 445. It becomes 445. Correct. Now, so now 4 should be decreased. After 4, again 2. Now again 4 should be decreased here. Right? That means 31 should be added. 445 plus 31, that is 476, not 470. Right? So plus 31 will be 476 and not 470. That means this logic is wrong. Now what is the next logic we can see? We can see that these numbers, okay, 47, 43, 41, 37. Okay, what are this? These are decreasing prime numbers. These are decreasing prime numbers. Correct. So these are decreasing prime numbers. Fine. So you can say 47 or this is a prime number. What is 43? Prime number. 41 prime number. So decreasing prime numbers consecutively, right? Decreasing consecutive prime numbers. So after 37 what should come? So after 37 what is the next prime number? 31. So 31 should be added, right? 410 plus 31 becomes 441. Okay. And after 31 what is the next prime number? 29. Next prime number is 29, right? 29. So 441 plus 29 becomes 470, correct. This is a logic, right? So what is the answer here? Answer is 441. Okay, I hope it is fine, right? This kind of concept, this kind of series you can detect any indifference by it could be anything as per examiner's wish, right? Now let's do one more problem. Okay, this is the next one. 241, 268, 332, 457. Okay, just go by the logic here. So 241 to 268, what is the difference? 27. What is the difference here? 268 to 332, difference 64. 332 to 457, what is the difference? 125, right? So by now you got to understand the pattern here. What is the pattern? What is 27? What is 64? What is 125? What is this pattern here? Right? This pattern is basically what? This pattern is 3 cube, 4 cube and 5 cube. Right, test cube is going on. So this next will be what? Next will be 6 cube, that is 216. Just add 216 in 457. So 457 plus 216 become how much? Becomes 673. 673. Right. Okay, I hope it is clear. Right. So just we'll see different kind of series and then we'll practice lots of questions. Okay. We'll practice different variety of questions. Just let me complete all the different types of series. Okay. Now, second one will be multiplicative series. Okay. Now, multiplicative series, that means that you can see that it means that something getting multiplied, right? Something getting multiplied. And normally, right, this multiplicative series, you can see that this multiplicative series normally, it increases very fast, right? It's a good way to, it increases very fast, right? Increases or decreases, I should say, very fast, right? Because something is getting multiplied. For example, okay, this is a question here, see. Try to get a pattern. So 10, 31, 95, 288, then blank, and then 2609. You got to find what is a blank number here, right? So now this is 2609, okay. So you can see starting from 10, then going to 31, then 95, then 288, and then 2609, right? So that you can say that directly, that series is increasing very fast, right? It's a fast increasing series. Fast increasing series, right? It's increasing very fast, no? 10, 31, then 95, then 288. After one blank, it becomes 2609. So it's increasing very fast, right? It could be multiplicative series. And what we should do? We should see multiply something, right? Suppose 10 to 31. So how to multiply something and get from 10 to 31, right? So nearest multiple of 10 near 31 is 3. Okay. So I should do like this. First one, okay, 10 to 31 is 10 into 3 plus 1. Okay. I should write 10 to 31 is into 3 plus 1. Correct. Now 31 to 95. 31 to 95. Okay. So again see what is multiply. So 31 multiple near 95. 31 into 3 is 93. So plus 2. Right. So it is into 3 plus 2. So I think we got the pattern, right? From here to here into 3 plus 1. From here to here into 3 plus 2. From here to here into 3 plus 3. Correct. So it should be what? Now this next one should be into 3 plus 4. So 288 into 3, right? So 300 into 3 is 900. Minus 12 into 3 is 36. So 900 minus 36 is 864, right? So for 288 into 3, first do 300 into 3 minus 12 into 3. 864 plus 4, that is 868. And just check when should be correct here. Into 3 plus 5. So 868 into 3. So again break the numbers. 850 into 3 is 2550. Next rest 18 into 3 is 54. 2550 plus 54, 2604 plus 5, 2609. Just fine, right? It's fine. This is the answer. Correct. So this is a kind of multiplicative series I was talking about, right? Multiplicative series I was talking about. Okay, you're fine, right? Okay. Now, let's do next one. Okay, so this is the next one here. 7, 7, 25, 141, 1023. Okay, what is the next number? So again, you can see this series is increasing very fast. Okay, this series is increasing very fast, right? 7, then 7, 25, 141, 1023. So next will be again bigger number, right? So again, it could be a multiplicative series, right? Something getting multiplied. So we'll see what is getting multiplied here. From 7 to 7, how should we reach? Just into 1, nothing else, right? Just into 1. 7 to 25, how should we reach by multiplying? So into, it should be 7 into 3 plus 4 or into 4 minus 3. Both things could be right. We have to see the possibilities, nothing else, right? So just see, it could be into 3 plus 4 or into 4 minus 3. As 7 into 4 is 28 and 28 minus 3 will be 25. It could be both the things here, right? Okay, then into 25 to 141, how to reach? So 25 into 5 is 125. It will be into 5 plus 16. Okay, into 5 plus 16 or subtracting 25 into 6 is 150. So into 6 minus 9. Correct. So we'll try to find a pattern now, right? Let me just do one more. 141 to 1023. Okay. So 141, if you solve it approximately, it will be like 8. If you do like 8 times. Okay. So if you calculate first addition, right? So just previous multiple will be 140 into 7, 980. So 141 into 7, 987. So into 7 plus 36. So one way is into 7 plus 36, or by subtraction 140 into 8 is 1120. Okay, 14 8 ja 112. So it is 1127, right? So it is into 8 and minus 104. Correct? Now see which pattern is right. It could be just plus 1 also, it could be just minus also, right? Which is going on. So you can see, easily observe here. Here we don't find any pattern. Here we don't find any pattern here, right? We don't find any pattern here. Here we can find the pattern, right? Into 3 plus 4, into 5 plus 16. So you can see here, into 3, into 5, into 7. So alternately it is going on. So next one would be into 9. Fine. Then plus 4, 2 square, plus 16, 4 square, plus 36, 6 square. So next should be plus 64, that is 8 square, right? So next is into 9 plus 64 is the next one, right? So what is into 9? So 1023 into 9. 1000 into 9, 9000. 23 into 9, 207. 9207 plus 64. 9271. 9271, right? Okay, I hope it is clear. Okay, now third one. Again, so I just will see all the basic types one, and then we'll solve practice problems, right? Okay, third is a kind of cubes and squares, right? Cubes and squares based series. Now, this by cubes and squares, I don't mean that normal 2 square, 3 square, it is a pretty common series, right? What I actually mean to say by this cubes and squares series is series like, you have to remember series like all the series, right? N cube plus n. Okay. N cube minus n. N cube plus n square. N cube minus n square. This kind of series, right, you got to remember. Okay. It is expected by you to remember this kind of series, right? So n cube plus n. So what is the series? Basically n cube plus n. If you put n as 0, you'll get this 0. If you put n as 1, 1 cube plus 1 becomes 2. If you put n as 2, 2 cube plus 2 is 10. If you put n as 3, 3 cube plus 3 is 30. Then at n at 4, 4 cube plus 4 is 68. Then 5 cube plus 5 is 130. 6 cube plus 6 is 222. 7 cube plus 7 is 350. And it will go on. So you should recognize, right, the moment you see this kind of numbers, you should recognize this is you see this is like 2, 10, 30, 68, right? You should recognize that this is a number of the form n cube plus 1. N cube plus n, right? Very important. Then n cube minus n. I'll tell you how the questions will come, right? N cube minus n. If you put n as 1, you get 0. If you put n as 2 cube minus 2 is 6. Then n at 3 cube minus 3, 24. Then n at 4 cube minus 4, 60. N at 5 cube minus 5, 120. N at 6 cube minus 6, 210. 7 cube minus 7, 336. 8 cube minus 8 will be 504 and so on. So go. Okay. Then n cube plus n squared is right. N at 0 it is 0. N at 1 it becomes 2. N at 2 cube plus 2 square 12. N at 3 cube plus 3 square 36. N at 4 cube plus 4 square 80. N at 5 cube plus 5 square 150. N at 6 cube plus 6 square 252. N at 7 cube plus 7 square 343 plus 49 392. 8 cube plus 8 square 512 plus 64 576 and so on. Okay, and then n cube minus n square. N at 1 is 0. N at 1 0 is 0. At 1 also it is 0. Okay, at 2 it is 2 cube minus 2 square is 4. 3 cube minus 3 square is 18. 4 cube minus 4 square is 48. 5 cube minus 5 square is 100. 6 cube minus 6 square is 180. 7 cube minus 7 square is 294. 8 cube minus 8 square 512 minus 64 is 448. Okay, 9 cube similarly to go on, right? So you should understand this pattern, right? What I want you to say is this 4 very important series, right? In exam, it's a bit difficult if you don't know, directly difficult to recognize that it's the n cube plus n form series, right? For example, you get a question like this. Okay, and this is a question here, right? So again, what you'll do see is, okay, this series is not increasing very fast. So let me go by the difference, right? So if you go by the difference here, the difference here is 2. This difference here is 10. This difference here is 30. This difference here is 68. So now, if you don't know what this 2, 10, 30, 68 are, it's very difficult to solve this series, basically, right? But now you know that, okay, 2, 10, 30, 68 is a n cube plus n. So what is 2? 2 is 1 cube plus 1. 10 is 2 cube plus 2. 30 is 3 cube plus 3. 68 is 4 cube plus 4. So next one will be 5 cube plus 5. That is 130. If you add 130, you will get 323. Next should be 6 cube plus 6. That is 222. So 323 plus 222, 545. Satisfying, right? That means therefore 323 is my answer. Correct. So you can see this kind of questions can be there. Okay. So you have to be very careful with this kind of questions here, right? All these questions are very careful with. Okay. So you should know this kind of this 4 kind of, you should know this 4 series. Okay. Next one is Fibonacci series. Okay. Fibonacci series. Notice Fibonacci series basically adding previous 2 terms to get a new next term, right? Suppose I write a series. This is 2. This is 3. So next term will be first 2 terms we write. Okay. Next is 2 plus 3. Next is 5. Next term will be 3 plus 5. That is 8. Next term will be 5 plus 8. That is 13. Next term will be 8 plus 13. 21. Then 13 plus 21. 34. Then 21 plus 34. 55. Then 34 plus 55. 89. Then 89 plus 55. 144. And so on, right? So adding every time 2 terms. How do you get 144? Adding 55 and 89. How do you get 89? Adding 34 and 55. How do you get 55? Adding 21 and 34. How do you get 34? Adding 13 and 21. How do you get 13? Or how do you get 21? Adding 13 and 8. How do you get 13? Adding 5 and 8. Right? Like this. How do you get 5 with 2 and 3? How do you get this 8 with 3 and 5? Right? So summation of every previous 2 terms is this is called Fibonacci series, right? Fibonacci series. So, right, sometimes questions are there on this. Okay, so you have to be like a very can solve it very easily, right? Suppose the question is, so this you see this kind of series here, right? 17, 26, 43, 69, 112, 181. So see, this is like, okay, difference of 9. Here difference of 17. Here difference of 26. Okay, here difference of 43. Correct. Here difference of 69. So by these numbers, right, you can't basically recognize anything. Once you take difference, you don't find a logic. Directly you can't derive. Okay. Second, if it's a logic behind it, the Fibonacci series, then it's fine. Fibonacci series. 17 plus 26, 43. 26 plus 43, 69. 43 plus 69, 112. 69 plus 112 is 181, right? So therefore 112 plus 181 will be how much? 293. So 293 is the answer. This is not the correct one. Logic, right? This is fine. 293 is the answer. It's a Fibonacci series, right? Fibonacci series. Okay, clear? Now, fifth one will be sum of digits series, right? Sum of digits series. So with sum of digits, right? Suppose now the question is 43, okay, 50, then 55, then 65, then 76, then 89, okay, then blank. So you can see here, right? So you can see the series, what is the series based on sum of the digits, right? That is 4 plus 3 here is 7. So 7 is added to get 50. Then 5 plus 0 is 5. Then 5 is added to get 55. 5 plus 5 is 10. 10 is added to get 65, right? So sum of the digit series it is 55 plus 10, 65. Okay. Again 6 plus 5 is 11. So 11 is added to get 76. 7 plus 6 is 13. 76 plus 13 is 81. Okay. Sorry, 89. Now what is 89 sum of digits? 8 plus 9 is 17. You add 17, you will get 106. So 106 is the answer, right? This is the sum of digits series, right? The digits can be summed up and a question can be asked on it. Okay. Okay, now so this is a question here. 13, 52, 59, 826, 842, 11, 788, right? You just pause the video and try this question for 2 minutes. It's a very good question, okay? You can clear the logic, get the logic, it's very good. Okay, I will solve it. See, so if you observe the series here, 13 into 4 is 52, right? So this is basically where this 4 comes from. 1 plus 3 is 4. So sum of the digits is 4, but in this case 4 is multiplied, not added, right? It is multiplied, okay? Then 5 plus 2 is 7. Okay, now 7 is added here, not multiplied. So it's basically plus into 4 plus 7. One time multiply, one time addition. Into 4 plus 7, right? Now 5 plus 9 should be 14. Okay. So it is multiplied then addition. So next should be again multiplied. So into 14, right? So 59 into 14 should give me 826. So you can do it easily. 14 into 50, 700. 14 into 9, 126. So 826, fine. Okay. So again, what sum of the digits here? 8 plus 2 plus 6. That is 16. You add 16, you get 842. Okay, 842 you get. Right? So you get 842 here. And this 842, again sum of the digits. 8 plus 4 plus 2 is again 14. 8 plus 4 plus 2 is again 14. So if you multiply 14, should get 7, 11, 7, 88. Right? Yes, you will get, right? So next should be again addition. Plus multiply, then again addition, right? What is addition here? 1 plus 1, 2, 2 plus 7, 9, 9 plus 8, 17, plus 8, 25. Okay, so 25 should be added. 11, 7, 88 plus 25, 11, 8, 1, 3. This is the answer. Okay, 11, 8, 1, 3. This is the answer for this question. Right? So some good problems and some basic types of series we have discussed here in this video. Okay. So now next video we'll continue with the series and we'll practice some problems. Okay, we'll practice different variety of problems with different logics on series, number series. Okay. Thank you for watching.